Right, just quick video to help you to solve the Terabeast problem for half-life. So it says here, determine the ratio of the number of cerium atoms in the sample when it was 100 seconds old compared to when the sample was 350 seconds old. So all they really mean by ratio is the difference between the start and the end. So the number of atoms before, at the start compared to the end. So first of all, we have to start by finding the half-life, and to do that we've got to use the graph. Okay, so here's the graph that we're going to use for both questions, and we know that the number of atoms of cerium 148 starts at 5 times 10 to the power 23. So it starts at that point. To work out the half-life, we have to go and halve the number of atoms. So half of 5 times 10 to the 23 is 2.5 times 10 to the 23, which is this point here. Alright, so I'm going to go across at that point here and draw a line, like so, and I'm going to go down here, and it lands quite nicely between 40 and 60, which is 50, like that. So hopefully we can see that that's the time it takes for the number of atoms of cerium 148 to halve from 5 times 10 to the 23 to 2.5 times 10 to the 23. And it's taken 50 seconds to do that. And we call that the half-life. So up here, what we can do is we can say the half-life equals 50 seconds. Okay, then what we can do from then on is look at the question again. Determine the ratio of the number of cerium atoms in the sample when it was 100 seconds old compared to when the sample was 350 seconds old. So we want to look at a period of time between 100 seconds to 350 seconds, and that's a difference of 250 seconds. Alright, so we want to know what happens to the number of cerium 148 atoms in that 250 seconds. We already know it halves in 50 seconds, so we've got to work out how many times it will halve in 250 seconds. So we do 250, okay, divided by 50 gives us 5, because 5 50s go into 250, so it's going to have halved 5 times. Okay, so it's going to have halved 5 times. Now, because it's a ratio, we always start at 1. Alright, so at the start we always have the maximum number of atoms, and because we only want it from 100 to 350, as it's a ratio, we might as well start it at 1 because it makes it easier. Then we've got to halve it 5 times, because we've said that 5 half-lives will pass in 250 seconds. Alright? Now, each arrow represents every time I'm halving it, so every half-life, so it's going to go to a quarter. Okay, and then it's going to go to an eighth, then it's going to go to a 16th, then it's going to go to 1 over 32. And you can see 1, 2, 3, 4, 5 arrows, so 5 half-lives, which means that's the answer. 1 over 32, which I know is a fraction, it's not a ratio, but that basically means there's what you end up with at the end. So after 250 seconds, you end up with 1 over 32 of what you began with, or as a ratio 1 to 32. So you started with a whole 1, and then after that 250 seconds you had 1 over 32 left, or 32 times smaller. Okay, and that's your answer.